I'm Clay Baenziger. I work for Bloomberg, and I work on our Hadoop infrastructure team. So I want to walk through and explain to you some ideas that we've come up with that we refer to as data Gloveboxes and data Dropboxes, and how they work, and some analogies of where these terms came from. With that, I grew up in Colorado near the Rocky Flats plutonium plant, so it was always kind of a specter over my childhood. And that may have had some influence, I guess, when thinking about systems architecture. The nuclear controls around nuclear materials handling is very rigorous, something that I think as software engineers we're really thankful we usually don't have to have anywhere near that much unless you work in life-critical applications. But with that, there are actually some interesting analogies we can think about for data. One of the things that right now certainly has a lot of us and a lot of the public saying, hey, I want to make sure that things are protected safely. And so what we're looking at here is actually a nuclear glove box. It's an isolation device to be able to help prevent this man here from being irradiated by the material that he's working with. And in fact, this is one of the last generations that was at the plant before they closed it down. You can see he's got robotics. He's able to actually have just normal clothes on. And all in all, he's able to be relatively relaxed compared to what you might think of when handling nuclear materials that are quite toxic and quite radioactive. But it's still worth us asking and walking through, what is Bloomberg? Because a lot of you guys might not know us, might not know why do we care about data? And what you're looking at here is the Bloomberg Professional Service. It's our kind of premier product, and this is why we have a lot of data that we have to think about. We were founded 37 years ago. We've got around 325,000 subscribers to our service. They span the globe, and with that, the really nice thing for us is we're a relatively mid-sized company by this point, where we've got 5,000 software engineers. We've got enough software engineers that we can really say, hey, we want to see the industry move, and we can implement some really cool stuff. In particular, for data, we've got now a cadre of about 100+ machine learning data scientists and engineers, and they say, hey, Clay, we want on your Hadoop clusters to be able to run some really neat analytics. But some of this data we need to protect, so that gives us some good thoughts here. We also have a very large news organization. Probably a lot of folks have seen Bloomberg TV or Bloomberg News in print. We actually have more reporters than the New York Times, the Washington Post, and Chicago Tribune combined right now. And we get about 125,000 sources coming in. So just the volume of data from that news organization is massive. About 1.5 million stories a day. So just the trickle of stories is still pretty voluminous. For distributing that financial information, folks don't always want to rely on the internet. That could go down. So we have one of the largest private networks in the world as well. And then with that, we actually tend to have some very high volume data. Every stock trade or offer to trade is what we call a tick. And we get 100 billion plus of those a day. So this stuff is very low latency and very latency sensitive, which makes our jobs fun on the Hadoop team trying to record all of those in various ways. And then, of course, there's just communication from humans, emails and what we call instant Bloombergs, instant messages coming in. So all of this data has different sensitivity levels and different concerns, and some of it needs to be treated very carefully. I'm sure your companies, you want to protect your customers the same, and you don't want to have to stand around like these guys in bunny suits to protect their data or protect you from their data. Here we see how plutonium was handled in a robotic system that looks like these folks were repairing. Normally, there would be no people in here, and it would just be a large robotic array of storage containers. So how do we do that for data, and why do we do that? Let's think about some of the properties that might be similar between radioactive materials and data, something we might not think about terribly often. So radioactive materials can be harmful to people in small quantities. We think about disasters, unfortunately, like Chernobyl and Fukushima, and we can't see a lot of this. Even when we're on the periphery, there's still biological effects, but trying to quantify that can be challenging. There's an incredibly long hazard life. For plutonium, it's plutonium-239, that isotope, is a 24,000-year half-life. So most of us won't really see that degrading at any reasonable quantity. And so kind of one of the prevailing thoughts is we should probably isolate these things to prevent their spread. We don't want to track them on our shoes when we go home if you work with them, et cetera. And we really need to catalog and characterize them. So again, that isotope of plutonium lasts 24,000 years, and it is less radioactive immediately, less radiations per second, to use a sloppy term there, versus other isotopes of plutonium that have much shorter half-lives. So we kind of need to know, what are these materials that we're working with? Same thing with data. Is this a social security number, or is this a news story, or is this a log from one of my servers? We've really got to be aware of that categorization and cataloging. So with that, we can still machine these things. We've been making, sadly, nuclear bombs for many years. We are able to operate in really micro-machining abilities there. And quite often, we can use robotics or personal protective equipment like those bunny suits. But data now, so it's also harmful in small quantities. I can't change my birthday. If it gets lost, that's been released. And it has a long hazard life. It's the entirety of my life that it can be a hazard potentially. Same thing for my social security number. Similarly, these things need to be isolated in my mind to prevent their spread. I don't really want everyone, just saying, hey, like, cool, I've got all the data to impersonate you now. I think most of us agree with that. And again, we need to catalog and characterize them. As I'd mentioned, data has different sensitivity levels. But again, we can't just throw all this stuff away and say, hey, we'll never touch it. It's too sensitive to work with. So how do we work with it? And a lot of us do continuous deployment and automated deployments. Similarly, there can be workflow automation. I've got this data. It's going to run through this machine learning pipeline, but I'm not going to look at the data. I trust the workflow, and I will look at the results, and I can verify that workflow. But I want to introduce this concept of Gloveboxes. So let's talk about how Gloveboxes can help us there with trying to do proliferation or hopefully data non-proliferation. So, and actually just for reference, here we see how nuclear materials sometimes deproliferate, luckily in our own country. This is very highly fissible plutonium going to Idaho National Labs to be collected there as they close down the Rocky Flats plant. So the data material proliferation can happen in a number of ways. We don't necessarily have attackers who want to blow up our data centers and spread our data, but we do have hackers that will hack our data and spread it. Similarly, accidental loss. This isn't intentionally nefarious, but we all might have data on our laptops or USB sticks or something like that. We've seen organizations very badly damaged and people's lives damaged from those losses. I think some key breaks that are worth mentioning are the Office of Personnel Management for the US government. 22 million employees had relatively their life story, every foreign travel, all of their family and their addresses, every place they've ever lived, as well as just general PII like social security numbers, birthdays, et cetera, leaked when that data set was hacked. Yahoo, if you've got friends who maybe use Yahoo, you still get spam from accounts with their same name and other domains, and that's because of Yahoo, unfortunately, having their address book get stolen. I think that was, there's a 3 billion email accounts with date of birth, email, and passwords from Yahoo in 2013, for example, got lost. Similarly, Anthem, the insurance provider, 78 million people there. These are really big, gross data sets. This is a Chernobyl-like incident in the data world. So, how do we prevent these accidental losses and terrorist kind of attacks, if you will, on our data? And we have to walk through, too, nowadays the regulatory environment's changing. Unlike for nuclear industries that have the Price-Anderson Act that says, yeah, you're responsible for only a fixed amount of money, and after that, well, the government will take care of it. Yeah, you just keep operating, don't worry about it. And, yeah, fault doesn't really matter. We don't have that. Certainly if you operate in the EU now with GDPR, that's a significant portion of your revenue if you happen to fall afoul of that. You have to be very cognizant of where your data is coming from now if you want to be able to mix it, because you have to be able to forget people. Similarly, there's data sovereignty laws coming about in many regions. And so now we have to actually think about how do we keep data isolated to where it came from. This is much the same as source control in nuclear materials, but we have to think about that in our data sets. And a lot of this, similarly, you must move the computation therefore, which is a challenge. Now, a lot of us, if we use Hadoop infrastructures or other systems, we can very easily move that computation. But a lot of this is beyond the scope of Gloveboxes and already well handled in the literature. We have technologies to prevent data swamps. Apache Atlas is a technology that aims to provide data lineage, for example, and data masking abilities with Apache Ranger. And these are relatively well known, but they aren't the full end-to-end philosophy of how do I interact with my data. We know cleanup is messy for these data sets, and we know that even if we know all of these things, I've got my data masked. OK, great. My data scientists may not be able to accidentally leak that data. But now how do I control the infrastructure on which they run on? I know lineage. I can verify where this data set came from. We had much of that at Rocky Flats when they had a fire in 1969 that spread plutonium over the Denver area. This is a picture of their cleanup. So how do we kind of envision what one of these Hadoop clusters looks like if we don't run on one today? It's a nice network stack with a couple different technologies. We've got Apache Yarn, which offers resource management, so I can actually move my compute to my data. We've got Apache HBase, which allows me to store my data in a nice controlled database. Cassandra similarly can run in this ecosystem very easily. And I've got HDFS, the Hadoop Distributed File System, which is a cluster spanning file system to make sure that my data is universally accessible. And then this all runs on various worker nodes that actually do my computation, store my data. And some really key things for us to start thinking about is, well, how do we make this Glovebox? How do I isolate my data? How do I actually validate where my compute's coming from? And so let's take a look at 3 of the protocols here. We've got a REST protocol for being able to submit applications. So Yarn is able to allow me to do job submission, job status, job log querying, and actually look at the UI of my application. And some of this is really critical to being able to build a contained infrastructure. Now I can actually say, hey, I've got one entry point to be able to make sure that an arbitrary application being run by a developer, they can't leak stuff out through their UI because I've got a central point there. Similarly, I can make sure that the logs have a maximum size that I'll return. Maybe you can tail your log for so much data, but after that, we don't want to allow data to escape incidentally. And then similarly, submitting the code and such, that's not the scope of a data Glovebox, but at least now I can make sure that the code's coming in. HBase, for example, has a different protocol, and this one's kind of interesting. We'll talk about why a protobuf remote procedure call protocol is a little bit more challenging than a RESTful protocol if you're just using commercial off-the-shelf technology to try to implement a Dropbox. And then we see that HDFS has a RESTful API. And again, HDFS also has a protobuf API, but the difficulties in an opaque, bespoke protocol make it a little more challenging to deal with. So for the sake of a Dropbox, using the RESTful API is really helpful. And we can see, just to kind of get some ideas here around what the methods might be here, on the HTTP method get, I can open a file. A really key part is I can get the checksum of a file. So I can validate what data I put in, and if that data matches what I thought I put in. Similarly, I can put data into the file system. That's always useful. It's nice to be able to actually store the data. And I can append data into the file system. So these standard REST API, so standard HTTP verbs here, get, put, post. And so now the question is, do I implement a Glovebox by just locking everything down? No, you can't access it. Well, it kind of defeats the purpose. I want to be able to manipulate my data. I want to see my data. And ideally, I want to actually get a work product out from this. Certainly the Rocky Flats installation, our nuclear arsenal has been distributed, so there was change in process controls to be able to move the material out despite guard towers, barbed wire. I think actually tanks were there, which was kind of just odd. But regardless, they were able to move material out. So how do we do this if it is a Glovebox? So that lock everything down challenge, we have firewalls. That's common in any IT shop, any network we're going to be operating in. But those firewalls have limitations. Firewalls can look at protocols. We can have deep packet inspection. But we don't want to just lock things down. We do want to allow permissiveness with user IDs, perhaps, and with actual context on the requests. Certainly encryption, certainly at rest encryption and on the wire encryption is rather key, and something that's provided out of the box in many stacks, HDFS, for example. Authentication, though, is key. And this is one thing that I think a lot of folks, as they move to AWS or Azure or Google Compute, how do you do authentication for your users? That's great, you've authenticated your services. That's great, you might have it talking to a single sign-on provider on the front door. But how do you pass that authentication through your stack to make sure that you know where those requests came from? And then similarly, limiting client connections. So I want to make sure that anything running in my ecosystem is limited on what it can talk out to, because just, I've made this Glovebox, everything's great, people have their hands in there and they're manipulating my data, and then they submit their code and it just talks to Google and puts it on Pastebin. Well, that kind of defeated the purpose. That was not what I wanted to have happen. So I need to limit outgoing client connections as well. And I want to motivate kind of an easy entry point to this with a Dropbox. And so what is a Dropbox? Well, it's kind of on the periphery of this lock everything down mentality. Data can go in, and you can put data in, say, through the HDFS REST API, but I can't get it back out. And so this is really useful for your data providers. Hey, we've got a website, it has social security numbers, and it's generating them left and right. People keep enrolling in our health insurance or whatever your industry happens to be, but you can append that data, but you can't read it back out. If that's compromised, for example, that store is safe. Those credentials aren't allowing it. And a lot of technologies have this. MySQL as well, you can implement similar things. But often we find in practice after a breach, these weren't done this way. Similarly, I need to provide validation to transmission, and this is where it gets a little harder. Some of the semantics with HDFS, being able to give me a checksum on the data that was put in is really useful. I can say, hey, I've got a local copy, whatever I uploaded, double check that what I uploaded is actually what I thought I uploaded. Cool, now I can destroy my copy because I'm positive that handoff was successful. And in our case, does it operate at the petabyte scale? And luckily for us, HDFS does. So what does this look like? Well, that REST API is relatively straightforward. I can do that put method to make a file, as I mentioned, and it does a transaction to be able to tell me, hey, I've got a metadata server, or the HDFS name node as it's called, and I'll send it to an HDFS data node. Now I upload my data, and it distributes nicely. Similarly, I can try to download a file, and so I'll say, hey, I want to open that file, and again, it'll do that same redirect, and the metadata server will say, yeah, go talk to this machine. Now I can download. And then that checksum, and the checksum is a key part here. So there's a number of different checksum algorithms provided, but I can get that back out, and I can validate the data that I actually put in. So if we want to implement this as a Dropbox, though, normally HDFS allows two-way access. Otherwise it'd be really difficult to build a cluster on this if it just, out of the box, no, sorry, you can't read any of the data you put in. And luckily, it's relatively easy to implement. The HDFS protocol, as I said, can either be RPC, and that presents a lot of challenges. Most commercial off-the-shelf technologies don't know that bespoke protobuf RPC, and they probably aren't designed, to work with protobuf or cap and proto or any of these serialization formats. But REST is really common, and luckily, it happens to follow a servlet-based design for its REST server. So we can actually do a typical filter on that REST server, and then it gets handed to the request handler, which is the WebHDFS interface. And so if you haven't seen a Jetty-based web service or a Tomcat-based web service before, the diagram here kind of gives you an idea. You've got a client, and in the last slide's example, it was just curl at the command line. It talks to an HTTP server that's really fast at moving the bytes, but it doesn't really implement much of the logic. And then I've got this Jetty servlet container, which has all the logic, and that's where we're concerned about because we need to implement some extra logic there. As I said, authentication is key. So one of the things that HDFS nicely provides is a Kerberos authentication stack so that everything can be Kerberized across the cluster. And in particular, now I can get a username. I want to motivate a concept called the DropboxFilter here, which will actually implement our ability to write and not be able to read back. And then furthermore, I provide that user info continuing down the stack and the typical WebHDFS logic. So what does it look like when this fails? So if we do a client request without authentication, you would normally get back, and it looks like slides have slightly moved around, but regardless, you'll see that you need authentication required in the blue box there. You get a nice 401. It's typical HTTP, has been around on the web for 20 years plus now. But now if you also do a request to read something back, you'll get a 403 authentication, authorization failed. And you'll be told that, hey, you can't actually read that. So this works out nicely. We can actually implement a Dropbox here. And we have code. One nice thing at Bloomberg, we try to do a fair amount in the open source community, so you can actually download this. If you have a Hadoop cluster, feel free to download it. Let me know where there might be bugs. And you can build this and drop this onto your own Hadoop cluster. So let's continue on down this path, though, of data Dropboxes. While researching this talk, one thing I ran across, for years we've been using this term internally of a data Glovebox. Folks usually stared at me strangely unless they knew nuclear material handling, so kind of nice to be able to explain that to them finally. But turns out the social sciences have had this problem for quite some time. Social scientists have said, hey, Census Bureau, really want to do something on current census data, and that's really sensitive. So what a lot of the social sciences have come up with is a concept called a data enclave. Usually this means somebody goes and sits in a room with a locked computer that's largely won't allow them to do anything other than look at the data, and they have maybe a notepad that a person will read on their way out. And we kind of think of this as the Pane here of these folks who all three have personal protective devices. They're wearing leaded aprons as they, I think, were actually assembling plutonium pits before it went up a dumbwaiter to the shipping department. Interesting aside, plutonium's pyrophoric. It bursts into flames spontaneously. When trying to find pictures, it turns out that in, I think, 2003, when they were trying to disassemble this assembly, they hadn't really thought about the fact that it was vertical instead of horizontal. And they were like, yeah, it burst into flames again, was the DOE report that I found. It was just kind of disturbing to be like, again. And they were like, this one was a little bigger, but it was OK. We controlled it. And then there was another later DOE report, and they explained, yeah, it had 15-foot flames, but it's OK. No one got burned in it. It was just like, I'm so happy this thing's going away. But regardless, we don't want our data scientists to have to tolerate the same kind of constriction that these folks were going through. And so that data enclave concept, though, like I say, tends not to have a concept of being able to have a production pipeline implemented in it. It tends to have this very centralized model, which by Cynthia's work was called the curator model. It restricts access, operations, and results, and it's pretty draconian about it. And furthermore, that curator must remain present throughout the lifetime of the database. So that means that if somebody's today doing joining social security numbers with billing records or something like that, that's fantastic, but that workflow in a curator model would have to be explicitly known by effectively a system operator. That'd be me in my case. And I don't want to know about data access patterns to that extent. We've got 5,000 software engineers. They're going to be doing all sorts of stuff. Just don't have time for that. So we got to find a more automated way to do it. Now, data enclaves as proposed by Lane and Ship, at least we're a little more open, being able to say, hey, let's make sure that we have direct and exact access, and let's make sure that we allow arbitrary computation. And so that was definitely a very useful thing. And actually, some other key parts. Direct and exact access is a very key thought here, and especially if you're trying to implement something like, say, billing again. Often there's statistical data controls where I can say, I'll return the data, but I'm going to fuzz it a little bit. And that works great, except for when you're trying to bill customers. They really don't like being told that you spent around this much money, just pay us that much anyways. So we need to find something that's a little more precise than that. And the arbitrary computation, again, we want our data scientists and our data engineers to be able to do the best that they can, so we can't constrain it. So again, motivating this isolation Glovebox technique is key. Here we actually see a man on the left is manipulating plutonium with his hands directly, but you can see that he's looking through a window there that's leaded glass to prevent the radiation from affecting him in his face nearly as much, and he's using lead-lined gloves to be able to actually manipulate that. And we can see that the process control is scaled up quite large at the Rocky Flats plant. On the right, there's tens of Glovebox gloves to move material throughout the production pipeline and to be able to unstick things as well if some stuff needed to be cleaned or otherwise moved around. And for us at kind of our scales, right? If you're running a Hadoop cluster and you've got hundreds or thousands of engineers on it, you've got to make sure that you've got automation in place. In their case, they had conveyor belts. And I think one of the greatest terms was the one on the right, the chainveyor, which happened to move material throughout the plant. For us, that's the same as running workflow automation tools like Apache Uzi or running Jenkins for continuous build and continuous deployment. So with that, let's try to kind of walk through and draw the analogies between that Glovebox and what we have. So that leaded pane of glass really needs to provide our data scientists some way to see the data, some way to actually interact with the data, but not to be able to take it away, not to be able to be contaminated with it. We don't want it on their local machines. We don't want it to be in their home directories on some box that's outside of that data Glovebox. And so this is often a remote desktop without download features. We want the glove ports. How do we actually make sure that they can, again, manipulate that data, but it's not on their hands? It's not in their GitHub repos or what have you. And that's usually the arbitrary code execution. So, we need to run code to manipulate it. This can be a slight change because they might be used to using Excel or other desktop tools. And that can still be implemented in the leaded pane of glass kind of area. We do need robotics either way. We need to be able to do deployment because you don't want your data scientists and data engineers being able to probably talk to like a GitHub repository directly. That would be, again, a great way to exfiltrate data, even accidentally. And then similarly for routine operations. You've got data coming in and maybe you need to batch it up into monthly or weekly files and whatnot. Pass-throughs in the Glovebox methodology were a way that you'd move material down and isolate the amount of material at any one station. We have the same thing. Firewalls are insufficient. You can have that protocol-aware deep packet inspection, as I mentioned, but it can't parse a lot of protocols. And so I can't actually be sure, like, is Clay accessing data /temp through, or is, junior data scientist who may just not have as good of procedural controls accessing temp foo. Similarly, the rule list becomes exponentially large as you get more users, so it doesn't really scale. Similarly, databases tend to be great pass-throughs if they have sufficient authentication, the ability to actually select, limit selects or limit updates. And then you have firewalls in the data Glovebox world, different than our IT world, which ensure user and workload isolation. So this is a key part, which means that if I write something to the distributed file system, somebody else can't read it who maybe doesn't have my project permissions, because we don't want to risk the contamination of data on that file system. Same thing for local file systems. And this starts to become quite a thought experiment for a systems administrator to try to think through where all is the data moving when somebody does this computation. And then similarly processing, how do I actually make sure that an application is running and it's not opening a network port that somebody else then opens and accidentally or intentionally connects to, and data flows that way. One of the nice things is if we're using Apache Yarn, the first two are relatively well handled by the fact that it actually makes a new directory for every application that it's running, and then it destroys that directory on completion, and that directory is only readable by the user who ran the application. So this helps limit how much I have to chase down at least. So kind of looking at that leaded pane of glass, we want to avoid overexposure to our data. And in doing so, we can do that by that limited RDP. Often you can set a Windows environment to say, hey, you can't use copy. Unfortunately, it also means you can't use paste, which is really limiting for trying to actually do any development. Certainly no file sharing and no ability to download files. So again, you have to worry about local files on your remote desktop system. I can't copy something if it's a Windows box from /Windows/temp if somebody else wrote it. And then you need to have that isolation for users for that reason. And it's useful to have tools. So you really have to think through the tools you want to provide. Not luckily the execution paths, but the tools such as, do I provide Jupyter and Zeppelin notebooks? Do they need SSH connections to the cluster directly? Do they need a JDBC client? And now we're kind of moving on to the glove ports and robotics side of things. You want to manipulate your data with code. So how do you do that? And with Apache Yarn, again, you can use SQL with Apache Hive. You could use Python and Scala with Apache Spark. One nice thing is you can actually arbitrarily run code. And Kubernetes is much the same as Apache Yarn for a lot of its primitives. So for the most part, this works out very well. You can do automation. Apache Uzi is a long-standing workflow management engine in the Hadoop ecosystem, and it'll allow you to, for example, automate those Hive and Spark jobs. But some really nice things is you've got to decontaminate your results when you want to get it out of that glove box. So what you can ensure is that maybe a role account that doesn't have a human behind it directly able to log in runs an Uzi job that is known, that says, hey, we're going to actually make sure that any data that has a lineage with any of these files can't go out of the cluster. And if it can go out of the cluster, we'll move it to an outgoing directory that's permitted. It's been decontaminated. Similarly, like I say, it can run non-human service accounts to be able to move that data for exfiltration. But one really nice thing, too, is Uzi's slowly growing the ability to do deployments. So recently it acquired a Git action, so you can actually point Uzi to a Git repo and say, hey, I want that on HDFS. So with the pass-throughs, kind of negative pressure is really required when you're handling small, fine-grained nuclear materials. Kind of in data, it's also required. We need to make sure the data moves only in the secure direction without explicit action making it work the other way. So again, you need to provide the process for data handoff through an environment. And this can be a challenge. Some techniques that we use are project directories, for example. So that way each project is well isolated. But how you actually limit so that one person's only in a persona of one project at a time, or that projects can cross-relate, still a challenge. Firewalls, again, they're mostly layer 4 TCP/IP devices, so we kind of have to throw them out. You can man in the middle SSL traffic and things like that. They can actually inspect and just say, hey, I don't recognize this protocol, and close that down. So they can still play a role, but for the most part, we need something better, and we'll explain how Apache Yarn's given us some better user-level controls for that. So we need to make sure that we've got a Dropbox for HDFS, and that Dropbox filter provides us so we can get data in, provides us that ability. And like I said, databases can offer this as well. So, for example, if you've got a MySQL database, you can make it a Dropbox with a grant for insert only for a user, or you can make it only readable. It's kind of funny because we're trying to isolate data, but it's a really useful thing to have endpoints on your network that are only readable. So the inverse of the Dropbox here, if I've got a MySQL database and it provides lots of reference data, Wikipedia corpus, maybe vital statistics from the government, just whatever interesting things you might need in your line of business, you want to be able to read those. You probably don't want to have to work on them in a data glove box type of lockdown environment, but you need to make sure whenever the data glove box talks to it that it can only read. Otherwise, it's a risk of exfiltrating data that you haven't vetted and otherwise made sure about. Similarly to those workload and user isolation firewalls, we want to make sure that our data doesn't spontaneously combust. Cleaning up chips was always a problem for Rocky Flats. You'd get those little plutonium shavings, and they'd, again, burst into flames. So with data, though, it's much the same. Oh, hey, yeah, that's right. We had a data scientist working on this project. He left this file around. Oh, hey, we had another data science project. We canceled it. But all the data is running around over here. So you really have to think about how do you do permissioning on data sets. In our case, we have Chef that operates on our clusters, and it goes through and it actually applies the file system permissions every time those machines are chefing, which is every 5 minutes per machine, to make sure that should anything have accidentally gotten changed, even though we try to design it so that it can't be, it gets set back to the proper permissions. Similarly, it keeps a log of that, so we know if things are getting changed. User collaboration locations. Again, we've got project directories and things like that, but you have to figure out how do we want to actually have our data pass through. And a lot of this is line of business and company specific. But then temporary and failed job data is a big problem. So on the HDFS, for example, the Hadoop distributed file system is what Apache Hive, the SQL layer, will use. And I might say, hey, I want to join 2 terabyte data sets. Well, that could result in quite a large data set. So it'll start writing data out to HDFS, and maybe halfway through, the user says, you know what, this is taking hours. I don't want to run this, and cancels it. You've got to make sure that all of your processes will clean up their temporary data, or wherever they're writing temporary data to gets cleaned up automatically for you. Those temporary data locations, like I say, so Hive can do that, the Hive warehouse. /temp on a Hadoop distributed file system can be just a dumping ground of all sorts of insanity. So you have to figure out ways to design your system so that they don't have these. It is possible to run a Hadoop cluster without /temp. I definitely advocate it if you've got a bunch of data there. And then local file systems as well. If you're running a Hadoop cluster as well, the users could be writing code that might be writing stuff to /temp, /var temp, or dev shared memory. So how do you clean that up? So kind of all the trash. And certainly, hopefully, we can do much better than they did for Rocky Flats. Apparently, the story here where this man's not wearing a bunny suit or anything and is dumping 55-gallon drums into an unlined pit just hanging out in the middle of Idaho, they were like, yeah, we really want to limit exposure, so the fastest he can dump the material, the better. And then they came back and realized, oh, yeah, when you dump a bunch of 55-gallon drums, they get beaten up and leak a lot. That didn't work real well. This great quote from Idaho National Labs was, the Department of Energy now considers Rocky Flats a triumph in the cleanup program, but much of the waste generated at Rocky Flats site isn't cleaned up. It's here in Idaho. So unfortunately, we'll have to deal with this yet again. Let's not do that with data. Private temporary directories are a great way to not have to worry about that. The Linux kernel has something called namespaces, user namespaces, and the PAM pluggable authentication module framework provides a namespace module. So one of the nice things about a Linux kernel namespace, Docker, for example, uses them to provide isolation, is that I can now take part of the kernel, the file system is what we're most concerned about, and I can actually say that for this user, that user, another user, they all have different views of what their apparent file system is. And with the PAM namespaces plugin, we can do that so that the initial mount namespace, as it would be called, you can see that there's a /temp. It's got inode 100. That's the file system identifier for that directory. We can know there's a poly instance or poly instantiation directory that is created here with some interesting directories that are also called temp in these cases with different inodes. And one of the key things here is that namespace module for PAM can say when the Clay user logs in, yeah, overwrite that temp directory. Basically do an overlay mount that he can't see at the kernel level to be able to take his temp Clay directory and actually make it his /temp directory. So now the user doesn't have to override any environment settings, any environment variables. As far as they know, they just have a completely empty temp directory. And everything that was working with either the initial mount namespace, maybe some daemon services, the root user, they have their temp directory that's still co-located, but everyone else is isolated. Similarly, that poly instantiation directory is usually permission bit zeros all across. So no one can just CD into that directory and read each other's temp directories. You can do this also with vartemp and devshm. And if you'd like to see an example of that, again, the open source code we have, there's a pull request into our chef repo on how to implement this. So we still need to keep the pipes flowing. Luckily, ours don't have the plutonium, but in the data, how do we isolate yarn? And one of the key things here is the code that's running. We have no clue what it is. We don't want to have clue what it is because the data scientists, they're prolific. There's only so many of us on the Hadoop infrastructure team. But one of the key things we have to think about is they still have to talk to the network. So Yarn has implemented a feature called, in Yarn 7468, that actually provides for Yarn to make sure that all of the traffic from every container that it spins up, not Docker container in this case, just Yarn cgroups isolated container, actually goes through IP tables or the host-based firewall. One of the great things about this is there's a mapping rule. So I can say, hey, all users, or each user has their own net classifier, as it's called, or net CLS in the kernel. And all groups, maybe this group for this data project or that group for another data project, have these other net classifiers. So now there's still manual work involved, but I can set my IP tables firewall up to be able to say, hey, user A can only talk to database A and B. should user A's application try to talk to web service A, it'll get a connection refused. It'll just pretend that that doesn't exist on the network. And similarly, one of the key challenges here is, of course, user B would have the inverse mapping, but this is still a distributed system. Hadoop, the HDFS, for example, Hadoop distributed file system is running on multiple machines, and it's network accessed. So I have to think about, how do I set my firewall rules up so that user B, for example, can access web service A that it owns, but also talk to all of the HDFS data nodes, can talk to its peers, should it be a Spark job where Spark launches network services, that a Spark executor needs to talk to its peers to get data. So when you write these firewall rules, best practices definitely have to kind of still be come up with for this. And if you're on the Kubernetes ecosystem, it's also possible to implement this. Look into the container networking interface. Project Calico is a great policy control layer for Kubernetes that can implement similar functionality. So with that, firewalls are important. This is from a different fire than the first fire picture I showed you at Rocky Flats, and turned out that they gutted their building pretty good, releasing plutonium again. Let's not do this, and let's just kind of walk through again what the primitives are here. We've got a leaded pane of glass, that remote desktop without copy, download, with user isolation to allow our developers to at least have a reasonable development experience the best we can offer. We need to have glove ports, some way to manipulate our data at an arm's length. We got to make sure it's still not something that they can drop on their machines. We need to have some robotics still in there. An infrastructure team endeavoring to do this has to think through processes and procedures and how to actually make those easy to work with for their data scientists. And we need the pass-through. How do we actually have the negative pressure to keep all the data going into the glove box and only with extreme intention leaving the glove box? And the user and workload isolation firewalls to make sure that we can offer this as a multi-tenant environment with multiple data sets. So with that, thank you guys for listening. And let me see here. I think I've got Slido up. So if anyone has questions, we can walk through them.